Morning, everyone. Good afternoon, good evening, good night, good something, depending on whenever you're watching this. We're doing Unit 5, Lesson 12 today, so if you need to hit pause on this video and then hit play when you've got Unit 5, Lesson 12 sitting in front of you. The learning targets today are, you'll have to excuse me, I had forgot to bring my tablet home like I intended. It's just sitting right there, so I did bring my laptop home like I always do. So everything I'm doing on the laptop right now, so I don't really have my ability to write on the screen. Everything I'm using right now is all mouse oriented, but it'll be all right with this lesson. But nevertheless, here we go. It says here, I know that the volume is the amount of space contained inside a three-dimensional figure, and I recognize the 3D shaped cylinder, cone, rectangular, prism, and sphere. Most of us probably do that already, but anyway, we're continuing our journey with volume. Today is just another, let's just build the concept of volume and volume shapes and how one can differ than the other, and then also maybe we'll dabble into little types of units of volume. But nevertheless, let's look at the warm-up problem. It says your teacher's going to show you some containers. A small container holds 200 beans. Estimate how many beans the large one holds. So here's the picture. The small one right here holds 200 beans. So how many do you think this one holds? I'll give you a clue. It's more than double. I'll give you a clue. It's actually more than triple. I'll give you a clue. It's actually more than quadruple. If you're wondering, wait, whoa, how could that be? Hopefully you're just reasoning and saying, well, wait a second. This larger container is not only taller, how many times taller, but it's also wider. And width, when it comes to containers, as we kind of learned in our activity yesterday, the wider something goes, it holds not just a little bit, but a lot more volume. So with that being said, go ahead and write down your answer. Your actual answer doesn't really matter. What matters is we're just looking at not only height, but we're looking at widths. In that case, if you're looking at a width, you're also looking how deep something goes. So volume, if you haven't guessed already, has 3 dimensions: a length, a width, and a height. So write down your answer. You don't need to worry about whether you're right or not, but we're moving on. The actual answer is 1,000, by the way, or about 1,000. So how close did you get? Hopefully you got closer to that after I told you it was more than quadruple 200. Now I'm going to show you some more containers, and we're hopefully going to get a little bit closer in our guesses. So I'm going to show you a picture of a pasta box, and that pasta box, if it holds 8 cups of rice, if you're going, wait, why is there rice in a pasta? It's just saying if there's 8 cups of rice, then how much rice would you need for the other rectangular prisms? So let me show you this picture. Again, the pasta box holds 8 cups of rice. So nope, I want to click here. So this one right here, the middle one, holds 8 cups of rice. So how much do you think this one holds? And that is a pudding box? So let zoom in? You gonna let me zoom? Let's see here. By the way, let's see if we can figure out any other information on this pasta box. Oh, they did kind of blur it out. We're going to see if we could see some other units on there. So it is kind of letting me zoom in, but not where I want it to. Over here. I hope I'm not ruining anything. Well, we're going to call that a pudding box. So on your chart, go ahead and put pudding box. And then you also have this chicken stock container. How much, if this is, I've already forgot. If that's 8 cups of rice, if this is 8, this one is 8 right here, then what is this? So write down pudding box and write down your guess and write down chicken stock container and write down your guess. And again, it's just a guess. But hopefully if you're looking here, you got to compare how many of these boxes do you think would fit into this? And if you look from here to here, no, it's not really letting me draw a line there. But, well, either way, what fits in that box, in other words, the depth of the box versus how wide the box is versus how tall, we got to be looking 3-dimensionals here. And I'd be hard-pressed to say that there is at least 1/4. That pudding box is 1/4 the size of that other box. So if that one is 8, what would be 1/4 of 8? Now this one's hard to say. I don't know if it's much different. It's slightly taller. Don't know if it's as deep. It's not as wide, but it's slightly taller. I'm interested in what you say. I'll let you write down what you think. But either way, you should have a pudding box. Again, I don't have my tablet, so I'm writing everything all on a mouse. But so be it. So you got the pudding box, and then you also have a chicken stock. So go ahead and write down your answer there. But remember, the middle one held 8 cups of rice. Then I'm going to show you another picture. If the pumpkin can holds 15 fluid ounces of rice, how much do the other ones hold? So let's look here. The pumpkin holds 15. So this one over here on the right, that one there, holds 15. What did it say? 15 ounces. Notice we're moving from cups, fluid ounces, which, believe it or not, is slightly different than regular ounces because you can weigh things in ounces. But anyway, 15 fluid ounces is the pumpkin. Come on, let me go back. There we go. Pumpkin is 15. So what do we think this oatmeal is going to be? Oatmeal container, and then we have a thing of tuna. So write down oatmeal and write down your guess. And write down tuna. The tuna is much easier to compare. It seems to me that the tuna and the pumpkin kind of have the same width. It's just a matter of how many of these stack on top of one another to make a pumpkin. So if this is 15, you can make that guess accordingly. And the rolled oats, I'll leave that up to you, but that's 15 ounces. I'll leave that up to you to figure that out. It's probably more than you think, though, those oats. And again, we're thinking about not in terms, I know the pumpkin would be ounces, it would be fluid, and then you're thinking, oh, this wouldn't be as much because they're oats. We're not talking about, if you were, that's kind of good thinking, but we're not talking about the space, because I know oats will have a lot of space in between them and obviously be a lot lighter. We're not talking about weight. We're just talking about if I were to pour water into this, pour water into that, water into that. If I poured water into this whole can, that'd be 15 ounces. My goodness, I'm doing this. This is, what's tonight? Tuesday night? I don't know if any of your guys if you can think back to Tuesday night, but the wind is absolutely howling. It's probably going to rip the plastic off our hoop house, which isn't going to be fun to fix. So now let's go back to, if the small cone, by the way, this is a vocabulary word and not too difficult. You could probably guess what a cone is. I wonder if you know the actual mathematical definition, but we'll get to that. If the small cone holds 2 ounces of rice, how much does the large hold? This whole time I was saying water. I guess I could have been saying rice. Wouldn't change really anything, but the small one holds 2 ounces. How much does the large cone hold? So let's go look at the cones. If this one over here holds 2 ounces, then how much does that one hold? That's 2. How much does that one hold? I'm curious because we're going to learn some formulas for finding the volume of cones. Some formulas, I mean a formula. I've already forgotten. I'm curious. I know that there's got to be at least, if in other words, if that was full, if we dumped water into this, how many of these do you think we could dump into that? If this right one was full of water, how many of these do you think we could dump into there? I guarantee it's at least 2. It could be a lot more than that, because once you start getting up here, this top section, even though it's cut out like that, but let's pretend it wasn't. But if you were, that's fine. This top section holds a lot of volume. We'll get into that more, but go ahead and write down your answer. And then finally it says if the golf ball were hollow, it would hold about 0.2 cups of water. So again, we got ounces, we got cups of rice, we got fluid ounces, and now we're back to cups of water. And here's another vocabulary word. We're going to learn a sphere. You can probably guess what that is. But especially if we're talking about golf balls and baseballs. If the golf ball were hollow and it held 0.2 cups of water, by the way, that's 2/10 or 1/5 of a cup of water. If the baseball were hollow, how much would it hold? So let's look at the the golf ball. This one here holds 0.2 cups of water. If I poked a hole in it and poked a hole in this one and I dumped this golf ball in there, how many of these golf balls, how much water in that golf ball would you think it would take to fill up that baseball? Again, looks like, oh my gosh, this golf ball is almost the size of the baseball, but you'd probably be surprised if you found out it was at least 3 of those golf balls to fill up that baseball, because we're not only talking about width that got bigger, but the depth, how far back the baseball goes. So we're talking about 3 dimensions. If you if you have 3 dimensions, every single dimension got tripled. So it's tripled, or it's one dimension got bigger, so did another, and so did another, and that all multiplies by itself. So you'd be surprised, but it's a lot more than you probably think, and we will discuss that. I'm just curious to see what you guys write down. We'll discuss that more when we get back. But this is just getting used to some number sense here, or some spatial reasoning, I should say. Now let's look at this. Again, this is just spatial reasoning here in activity 2. It says, what shapes are the faces of each type of object shown here? What faces are each type? Well, if we want to, we could quickly try to go back to activity 1. if we're looking there, if you want to look at some of these answers. The baseball, if you noticed, that's almost 5 times as much. Some of you might have said double, but the baseball is almost 5 times as much. So anyway, let's not get sidetracked. I guess that was 4.5 times as much volume. Where is it? There it is. This baseball is 4.5, almost 5 times. I know it doesn't look 5 times bigger, but we're not talking about length, width, or height. We're talking about volume. We're talking about volume. The volume is almost 5 of these, almost 5 of these, 4.5 of these golf balls. The liquid inside these golf balls would fit in that baseball. So back to activity 2. It says, what shapes are the faces of each type? What shapes are the faces of each type of object shown? For example, all 6 faces of a cube. Oh, here's my best attempt at a cube with. Not the best cube with a mouse. But all faces of a cube are squares. 1, 2, 3, and then you can't see behind, but underneath and behind are 5, 6. They're all squares. So every face is a square. So what shapes are the faces of this? What shapes do you see? Well, technically there's 3 different shapes. There is this shape right here. That's a rectangle. There is this shape right here. That's a rectangle. And then we have one that's almost identical but slightly off. We have this shape right here. That's a rectangle. So it's got 6 faces but 3 shapes, because every side has its matching side on the opposite side. So what about this? What about B here? What shapes are the faces of each type? So go ahead and write that down. You could just say 3 different rectangles. Well, you're probably noticing one face right here, meaning just because it's on its side, I could set this up and you notice that would sit right on there. And that's, we're going to call a circle, even though it looks like an oval. It's a cone. And if you're going to draw a cone, you wouldn't draw a circle. In art, you probably learned that you got to give it perspective. But nevertheless, you got a circle. And what about the rest of the shape over here? What are we going to call that? That's another face. There's that base right here. And I kind of just answered that one there. And then there's the rest of it. So I'll leave that up to you. But technically what you're just going to say is, well, we've got a circle as the shape. And this is some curved surface. Who knows? It's curved. So that's all we got to say. What shapes are the faces? We've got 2 faces. We've got a circle, a flat 2-dimensional circle. And then we've got, that's a 3-dimensional curved surface for the other one. So part C, what faces, what shapes are the faces of this? Well, hopefully you're noticing we've got 2 circles, so you could write that. You might not see it, but there's another one here. There's 2 circles. And then again, another curved surface. And we'll learn a surface area for that. If you remember, you can actually take the wrapper off of that. You don't need to write that, but you could call it a curved surface. You could technically also call that, a rectangle that got wrapped around that can. This one, what would you call that face? Well, again, you can just write down a curved surface. I have no idea, but either way, you can't really flatten that one anyway. That's for sure. So you could just write down a curved surface. Again, it's just getting our spatial reasoning kind of wrapped around 3 dimensions again We haven't talked about 3 dimensions in a long time. We haven't talked about volume in a long time. So we will be learning how to find the volume of that with a simple formula, and the volume of that with a simple formula, and the volume of that in the simple formula coming up soon. Now it says, which faces could be referred to as the base? If you guys don't know what base means, first off, back up to the vocabulary. This is a cone. Back up here it says a cone. We kind of probably suspected that you knew that. And this is a sphere. Mathematical term for that ball is a sphere. So it says, which faces could be referred to as the base of the object? Well, for A, any of these rectangles, any rectangle works as the base because it'll sit flat and nice and firm. B, on the other hand, if you want to know the base, it's kind of like saying, how could you set this down on a table without it rolling away? Well, that means that the circle is considered the base. Which face could be referred to as the base? Only the circle side for this. And that's technically true for question C. The base of C, how could I set this down and not have it roll away? Well, you would have to put it on either circle, on either end, so to speak. But the base of C is also a circle. And then letter D. This one's a tricky one. Can you guess what the face of this one is? The face of this one, maybe you can guess, is actually a circle. Why is it a circle? Well, technically the face of this, which I don't expect you to know this, but if I were to cut this in half, kind of like that, it's not the best, but technically there is, the way that you look at a sphere, the way we'd have to look at that is actually 2 hemispheres, which a hemisphere is a half of a sphere, and then you have a base. But no big deal. Like, there is no way you could set that down without having it roll away unless you cut it in half, in which case when we're talking about spheres in the formula, we'll have to pretend that there is a circle in the middle of that, because we will be talking about the radius and diameters of these spheres, and the way you look at that is you have to look inside the circle. So last but not least, you'll notice this is a pretty simple yet effective lesson at just building the concept of, or simple yet necessary. I don't know how effective it is, but lesson at just building some volume sense. Problem 3 says, here's a method for quickly sketching a cylinder. Draw 2 ovals, connect the edges, and then it says which parts of your drawing would be hidden behind the cylinder. Make these parts dashed lines. So it didn't really do that, but what it's saying to do is, if you want, and I don't think I can, well, I can, I'm going to have to do it like this. It says practice sketching some cylinders. Sketch a few different sizes: short, tall, narrow, wide, and sideways. And label the radius R and the height H. So if I were to label this one, first off, I think actually I can. What it means by drawing a dashed so you can see on that, it said, when it says make the parts that you can't see, make these parts, which parts of your drawing would be hidden? We're going to pretend that, make these parts dash lines. That's kind of what I just did right there. It just means that you can't technically see that part. So if you make it a dotted line, you can't see it. But we can technically see everything on the top, but you can't see the bottom. So long story short, practice drawing a bunch. Draw an oval. Draw another identical oval. That's nowhere near close to identical. Keep going. Attach them. Holy cow, it's hard to draw with the mouse. And you have that. And then it says to make the part that you can't see a dotted line. So technically, if I were to do this without, I would draw a dotted line and then make it solid and go, give or take. Now here's what we haven't done. It says label the radius R. So if I was to label this, the radius, if you remember, the radius is from the center of a circle to the edge. That is called R. Now the height of this is from here to here. That is also the height. So I could have just wrote an H right here, and technically that means what we're talking about is from here down to here. Now it also said do some sideways, so we could technically do it like this, but guess what? If I did it like this, the height is not from there to there. That is not the height. That was an H, by the way. Holy cow, that's definitely not an H still. That is not the height. Just because it's on its side, the height would still be right here. From here to here. Technically the middle to the middle. And the radius is still from here to here. So go ahead and finish drawing like it said, a short one, a tall one, narrow, wide, sideways, and then label each one with a radius and a height. And then that'll be just about it. Then you can look at lesson 12. And I don't have this pulled up with Cami right now. I guess all I have to do is click there if I wanted to. But lesson 12 practice problems. It says sketch a cube and label its side length as 4. And if you go back in the video, I kind of showed you how to draw a cube. But that's just kind of like you draw a square to the best of your ability. And then you can draw a couple little dashes, and then they should be all parallel, but it's roughly like that. So you can do that. Part B says sketch a cube with sides that are twice as long cube A and label its side length. This will be cube B. So you're going to draw one cube and label the side length as 4. And then it says find the volumes of cube A and cube B. So you're going to notice if you do this, to find the volume of a cube, by the way, it's length times width times height. It's 4 times 4 times 4. And then on this one down here, you're going to do 8 times 8 times 8 because each side length will be 8. 8 and 8. You're going to notice when you doubled the side length, the volume definitely did not double. It got a lot more than doubled. And problem 2 says 2 paper drink cups are shaped like cones. The small cone can hold 6 ounces of water. The large cone is 4/3 the height and 4/3 the diameter of the small cone. Which of these could be the amount of water the large cone holds? Well, 6 times 4/3 is going to be 24/3, which is 8. So it would have been nice if they just would have said the large cone. Well, I guess it's just saying it's 1 1/3 higher and 1 1/3 wider. Doesn't mean the volume. I guess what it's trying to say is the volume is definitely not just 1 1/3 times, because the height got bigger. And if the diameter got wider, that's essentially the width, which also means the depth got 1 1/3. So it's a lot more. And notice it's pretty much wanting to see, are you paying attention to the units? 6 ounces. Probably don't want to talk about centimeters. That's not a volume. probably don't want to talk about centimeters here. And we don't want to really talk about the larger one being less. So by process of elimination, I don't even know why I bothered doing all that math. But notice that the height and the width got 1 1/3 wider, but the volume almost tripled, more than doubled. So, and then problem 3, the graph represents the volume of a cylinder with the height equal to its radius. When the diameter is 2, go right down here to 2, what's the radius of the cylinder? Well, first off, we do know that a radius is half of a diameter, so that one's pretty simple. And then it says express the volume of the cube. Express the volume of a cube of side length S as an equation. The graph represents the volume of a cylinder with a height equal to its radius. Express the volume of a cube, the side length S as an equation. This is kind of weird. I don't even know why they give us all this graph and everything. Maybe it's because of C and D. I was going to say we didn't even need the graph for A and B. But either way, for B, it's going to be S times S times S, or S to the third. That's how you find the volume of a cube. And down here it says make a table for the volume of a cube when the side length is 0. That's a hard one. 0 times 0 times 0. Side length of 1, 1 times 1 times 1. Side length of 2, 2 times 2. So in other words, you're going to make a table. On one side, you'll have the side length. On the other side, you'll have the volume. And so forth. So that's pretty straightforward. And it says, which volume is greater? The volume of a cube when the side length is 3. Well, that's 3 times 3 times 3. That's going to be 27. Or the volume of a cylinder when the diameter is 3. So that's when you go right here and you go up from 3, and you can see right here that the volume would be 11. So, and then it says select all the points that are on a line with slope 2 that also contain the points 2. This problem, don't worry about it. This is that one lesson that we kind of skipped. So, so that's it. That's it. Call me, or not call me, email me if you have any questions or concerns, and I should be able to get back to you in a reasonable amount of time. Other than that, if you like this video, don't do anything. If you didn't like this video, please hit that like and subscribe button. Other than that, peace.